information from the August 28th lecture where we started learning about vectors. First of all, it's important to know the difference between a scalar and a vector. A scalar is a quantity that only has magnitude but no direction, and a vector has both magnitude and direction. And for this class, some important notation is that an out-of-page vector will be indicated with a counterclockwise arrow, and an into-page vector will be a clockwise arrow. Some more important notation for this class is that any vector will be shown with a bar over top of the name, as shown here, and then the magnitude of that vector will be the name of the vector inside two absolute value lines. Some useful trig rules for this class are the cosine law and sine law, which, depending on the information given for a problem, will be useful to find the unknown information, such as an angle that you'll need or a side length. There are two main ways to solve vector addition. First, you can use the triangle method, where you put the vectors that you are adding together, you put them tip to tail, and you find the third side that is formed between these two vectors. So in this case, P plus Q would be R, which is A to C. And the second way to add vectors is to put the bases of the vectors together, and based on the parallelogram they form, you would solve for the diagonal, which comes out to the same answer that you would get using the triangle method. And for vector subtraction, it's relatively similar to addition, but you can also use relative position, where you would put the base of the vectors together and find the vector that is made from the the heads of both of the vectors. And then you can also add the negative, where you would use either the triangle or parallelogram method. Multiplying a vector by a scalar is relatively simple. It would simply change the magnitude of the vector, and here are some simple criteria to remember. And here's an example of if a vector was multiplied by the scalar of 2, you can see that it simply increases the magnitude but does not change the direction. Unit vectors are also an important concept for this class. It's important to know that these do not have any dimension, or they have a dimension of 1, so they're unitless, and they have a magnitude of 1. And they are simply used to indicate the direction of a vector and not any magnitude. And you would use a hat to indicate that there is a unit vector being used. Some final notes on vectors are that for any vector v and w, the magnitude of v plus w will always be less than or equal to the magnitude of v plus the magnitude of w.